Professor Jagdev Singh from Jagdev Singh from IIA for kindly accepting our invitation to deliver a talk on his first mission to Antarctica. We have been conducting these talks for the benefit of our teachers and students on a variety of topics, all the way from quarks to cosmology, with the intention of informing our teachers and students about developments in various fields apart from their normal areas. It's a kind of a continuing education scheme, one can say. So we have conducted talks from quarks to cosmology all the way with the help of faculty members from colleges, universities, and research institutes. We are very thankful to them. And we have also conducted talks in Kannada, also the regional language, with the view of encouraging the usage of Kannada in higher education, considering the problems faced by teachers and students. Ultimately, we have to switch over to Indian languages, but when that happens, we don't know. So we are making an attempt to use the language at the higher levels. Let us see how it goes. So today we have a very distinguished speaker from IIA, Indian Institute of Astrophysics, Bengaluru. He will speak about his experiences in the first Antarctica mission to study the sun. So he will speak about for 50 minutes, followed by a question answer session. So before I request him to speak, I request his former doctoral student, Dr. Paniveni, to just introduce the speaker. Over to you, Dr. Miller.
Thank you, sir. Good morning and a very warm greeting to all of you. I deem it a great pleasure and privilege to read out Professor Jagdev Singh's profile, as he was also my research guide. Professor Jagdev Singh joined Kodaikanal Observatory as a scientist in 1974 after his postgraduate qualification in physics. Subsequently, he registered for his PhD at Punjab University, Patiala. For his research work, he made use of observations made during the total solar eclipses of 1980 and 1983. Thereafter, he led 10 expeditions to make observations during solar eclipses occurred in different parts of the world. He also led an expedition to Antarctica region to observe the sun round the clock without the interruption of day-night cycle. It was the first expedition to Antarctica to study the sun at midnight. He designed, developed, and used state-of-the-art digitizers to digitize the solar images obtained at Kodaikanal Observatory. He developed a new methodology, that is equal contrast technique, to analyze the calcium K images of time series data obtained at different observatories uniformly. He made numerous trips to Japan to study, observe, and further study the solar corona using multi-line spectroscopy. From the high-resolution spectroscopy of emission lines, he found the decrease in width of green line with height in the corona for the first time. With the experience of developing instruments to be used during eclipses and observations with coronagraph in Japan, he felt the need for space coronagraph. He is the founder principal investigator of the visible emission line coronagraph, which later on came to be developed as Adithya L1 mission. He has published more than 150 papers in the international and national journals. During this talk, Professor Jagdev Singh will discuss the need to go to Antarctica and preparations that have to be made before going there for astronomical purpose. There are features on the solar surface known as large convective cells or supergranulation, which have an average lifetime of about 22 hours and average size of about 30,000 kilometers. To know about the physical and dynamical properties of these features, one would like to obtain the relevant data without the interruption of day-night cycle. Antarctica region offers such a possibility. In spite of the very harsh weather conditions during the expedition, the team was very lucky to obtain the images of the sun in calcium K at 39-34 angstrom for 106 hours continuously at an interval of 5 minutes. Using this data, it was found that the cells near the sunspot region live longer as compared to those away from the sunspot. That's quiet regions. Professor Singh will also discuss the various other topics of the expedition. Thank you very much. Over to you, Sir Professor Jagdev Singh, and a hearty welcome to you, sir.
Yeah, please, you can start your presentation, sir.
Good morning. Thank you, Dr. Kagali, for arranging this talk, and for Dr. Paniveni, for the nice introduction and kind words. Before I go to the physics of the sun, I would introduce to the Antarctic region and its various features. Uh, Antarctic region, as you know, is covered with ice, hard ice and snow. India has two stations, permanent station. One is Maitri and another is Dakshin Gangotri at the edge of the Antarctic region at a latitude of about 72 degree. Dakshin Gangotri is on the ice, whereas Maitri is on the land mass. Uh, Generally, most of the region is covered with ice and snow. And what during the winter, and this at some places the ice melts and you see the landmass. Metri is stationed at landmass here. You can see a couple of small hills here, and Metri is one of the place where the India has permanent station. And there are two teams which go to Metri. One is summer team, another is winter team. Mostly landmass is covered by ice and snow. At few places, the ice melts during the local summer. And then motivation for the Antarctic expedition. In earlier days, most of the expedition was there to search this seafood and catch the whale and take them to the landmass to Japan and various places. Various countries had the expedition, but they are mostly conducted for the seafood. Uh, and then what during this process, number of ships were destroyed or lost in the sea, and lot of people died due to that, and sometimes ship also sank. In 1915, there was an endurance ship which sank, but they could save most of the people by using the boats and other things. The ship has some boats, so in case of emergency, the people get to the boats and then move away. Modern days purpose, that was earlier days, but then the purpose of the expedition became the search for the deposits of precious metals. People thought they are deposits of precious metal like diamonds, rare earth elements, deposit of radioactive elements, and such as uranium. So people want to exploit that. So expedition started. After a detailed study, it was found that only mica is available, and that too in not big deposit, not in big deposit, but embedded in stones, nothing else. The mica is very fine, and it is very difficult to take out the mica from the stones. Percentage is very less. Presently, expeditions are made for the scientific, political, and social reason, whether uh, whether geographical studies and astronomical purpose. So nowadays, the idea has changed to study the condition on Earth in the earlier times by investigating the frozen, undisturbed samples of ice in the deep layers of the snow or ice. Since ice is falling every year, but the quality of the ice depends upon the deposits. So, over millions of years, the ice is deposited. It has become so doing the by doing these uh, taking the deep samples by and then studying them, you can study what was the condition millions years before. To explore the sun in the past by studying the deeper ice samples indirectly as the activity of the sun affect the snow deposits every year. To study the sun and stars without the day and night cycle. So you can since during the local summer, sun does not set at all, and so you can see the midnight sun. The expedition, we made the study. We made the expedition to study physical and dynamic properties of the calcium network on the sun. And Dr. Panivani also given the summary of these large convective cells. Now, who can go from India? Basically, it is government-sponsored expeditions. It is very expensive. It is for individual. It is not possible to go until they are not. Presently, some European countries and Americans have started expeditions, but they don't land there. They just take the cycle of the Antarctic region and bring you back, but you can't stay. So, in Indian government, every year they send the expedition, which consists of the scientist, and generally ship goes every year for 4 months. Okay, I'll come to that. Scientists who can go? Scientists make presentation. Scientists make presentation about their project in the review committees to show that it can be done only from Antarctic region, that you cannot do anywhere else, but only it can be done, and it is important to study. After the recommendation of the review committee, feasibility studies are made to conclude that it is possible. Okay, sir, you may justify scientifically, but whether it is possible to be done from the Antarctic region, that has to be studied. If required, new instruments suitable for operation in the Antarctic region are developed and tested. The physical fitness of the scientist going to is tested in great details. If found good, training is given in the high altitude cold places, mostly in Himalaya region, to face the harsh climate condition and identify crevasses and avoid these crevasses while walking on the hard ice. So if after the training, if you are found fit, then only you are allowed to go there. During the training, your health conditions are monitored like BP and other things. Since it is an unknown place for the person going for the first time, we need to know what is available there and what we need to carry with us. So some materials might be available. You may need some materials, like cement or some wood things. You cannot carry all the material. You carry only the instrument. What other material you need, so if they are not available, you have to carry them. If possible, try to meet the person in the earlier expedition. We met one person and got more information over that. So we were given the training at the Kullu Manali range, where is at high altitude. So you can see we have to go through the hardship. We have to carry the weight at our back, so that they want to test whether you can carry the weight and other things, etc. There were Air Force personnel and other things, etc. So this is how we went through the training for about 3 weeks, walking every day, 10 kilometers, 15 kilometers, carrying the weight of 10 to 15 kg at our back. But when we were coming back, then some shooting was going of Hina picture. So people enjoyed that also. So before going for the expedition to Antarctic, we have to meet the Secretary DOD, Department of Ocean Development. Vinod Gaur was the secretary at that time. We had to explain him what we are going to do there, what we have at present. He will ask, are you ready? What equipment you have brought, and whether it will work, not work. So he will have some question answers. We have to sort of satisfy him that everything is ready. We have all the required equipment and required information about the Antarctic region. Then at Goa, we assembled together for about 3-4 days. and then ship comes there. It is ice class ship which has double hull. It can break the ice when it is stuck to the in a, sea freezes in the Antarctic region in the winter. So when you are going, so there is a ice, hard ice. So the ship is capable of breaking the ice. So finally we met there, and the team consists of scientists. 26 of the scientists were there from various fields, from geology, from uh, earth sciences, from nuclear sciences, astronomy. We were three people were there from the astronomy. One from GST Babu from our institute, and Dr. Bahavuddin from the Nainital Observatory. So scientists, Air Force personnel, Army personnel, Navy personnel, crew, summer and winter team. So totally there were 86 people. Air Force personnel generally takes care of the helicopters going from one place to another place. Army personnel takes care of the mechanical system at the station, Antarctic region, Antarctica, various vehicles. They have a lot of vehicles, generators and other things, etc. Those are taken care of by the army person. Navy person takes of the crew. Navy person takes care of the communication, and crew takes care of the ship. They comes with the crew. They are not our Indian people. They are from the ship. And there are two team part of the team. It is 26 people. One is summer team, another is winter team. Summer team goes for 4 months, whereas winter team goes for 14 months. So they go in November, and then they come next March, whereas summer team comes back the March after spending 4 months there. So this is this team which was from BRC, from Hyderabad, from various organizations, these things, etc. So while going to the Antarctic, beginning sea is quiet near the equator and other thing. Once we reaches, we come across skua. Skua is a bird which is very large, and it can fly hundreds of kilometers without any rest, without any sleeping on the sea, since it is on the sea. So whenever it wants rest, it is just lows down. The why it flies so much is that it does not use its wings. It just flies along the air currents. So that's why it can fly for a long time. So then becomes 30s and 40s, 50-degree latitude. It becomes screaming and crying 40s and 50s. What happens, ship becomes very unstable, and then we have to wind up every material in the boxes kind of a thing. And it takes about 2 days to cross over this rough sea. So during that, we have to live with only soup, and not people get seasickness and other things. After that, sea becomes when we reach 60 degrees, sea becomes little quieter, and then you see the icebergs here. Icebergs are broken um, pieces from the Antarctic region. Then once we reach Antarctica, we come across the frozen ice near the thing. Then the ship could not proceed further. Then we have to find out how the path is there. Then we took out the helicopter from the deck, from inside, and then helicopter went around and saw where is the least ice deposit. So after looking at that, then ship continued, and then we reached the Antarctic region, and then ship docked there. From there, we have to go to the Metri station by helicopters. So now I come to the sun. You see, the sun, generally you see, is basically yellow ball, and which has a black spot, sometimes black spot, which are known as sunspot. I will not go into details of that, but these are the seeds of high magnetic field. And this is calcium K picture of the sun. taken
Oh.
from Kodaikanal Observatory. You see
Excuse
the
me,
flashes,
excuse me,
and
Professor.
around that there's a network.
Excuse me, we are not seeing the slides. Slide movement is not happening.
Oh.
We're not seeing the movement of slides.
Oh, is it?
Yeah.
Yeah, slides are not moving.
Oh, you have not told earlier.
Yeah. You have to use the arrow buttons.
I have
Okay.
now it is moving.
No, not yet.
Not yeah.
Go to-
Only the first slide is seen. That's all.
Yeah. Go to the right arrow or left arrow for moving the slides on the finger.
Now?
No movement
Now?
of slides. No.
No. I'm using the arrow only.
Right
Wait,
arrow.
wait.
Press the right arrow on the keyboard.
Now
No.
I am.
Yeah, slide is not moving. I don't know why. You press enter. Maybe please enter and see.
Okay, enter. Let
Enter.
me see. Now,
No, slide movement is not there.
what I should do?
Make it maximize first, sir.
Next slide.
X.
Next slide.
Um,
Go to resume the slideshow. Go to resume the slideshow. That's what one suggestion is. On the left hand side, there's okay. Now from the slide. Yeah, please.
Double
Yeah, from the beginning.
yeah.
Press that.
Now,
No. Again, resume the slideshow. Please click that.
On the second slide, sir. You click on the second slide.
Second from the current slide. Second one. Okay, current slide. Okay.
Now you click on that. You click on the second slide.
Down arrow.
down arrow I'm doing.
Yeah, on the this thing. What is that? Keyboard, down arrow.
I'm doing down arrow only.
It's not moving.
I think there is an icon on that down arrow on that icon from current slide.
Number two. Number two. Go to the next number. Second one.
Yeah.
Second one. Go to the second slide. Click on the second slide with the arrow.
Okay.
Yeah. Click that. Please click.
Now
Yeah.
it is coming.
Moving. Yeah. Please
Okay.
now press the
Okay, I'll use
arrow buttons. I mean the right arrow. Right arrow. Down arrow. Sorry, down arrow. Down arrow. Correct. Yeah. Down. Okay. Now we are seeing. Yeah. Please down arrow. Correct. Yeah. Now we are seeing. Yeah. What is the purpose? Yeah.
Okay.
Motivation.
Okay. So I shall quickly go through the slides.
Yeah,
This is Antarctic region. This is where is the landmass is there, and this is where I talked about the ships being lost, kind of a thing, broken by the ice and other things, etc. These I already explained about the purpose of the thing, and then I explained how we plan for Antarctic region.
Down arrow.
Sir, excuse me, sir.
Hello, sir.
So
Please,
slideshow,
give
can't
some time
you
to
try,
read
sir,
the
once
slides,
again?
sir.
Slideshow is better.
No. Give us some time to read the slides, sir.
Okay.
Because, go to the third slide, sir. Third slide. Yeah.
Third slide. Is it okay?
Yeah.
Sir. Next slide.
Slideshow mode is better, sir.
Unfortunately, that's not happening. I don't know what's the problem.
Next
Why
slide,
it is
sir.
not slideshow is better, but it is not working.
Go to the down arrow now. Now down arrow.
Next slide, sir.
Next one. Fourth arrow.
Sir, instead slideshow from the beginning can be done.
Yeah. Sure. Let's sir.
Is it okay?
Yeah. Okay now.
Yes, sir.
Okay.
Give us some few seconds to read.
Yeah,
Sir.
slideshow from the beginning, then slider, sir.
No, he has
If
been
I press
trying.
this,
He has been trying that. Somehow it is not responding. See, again, this some problem there.
and
Why?
you see, it is not responding now.
Yeah,
Now you are not.
Please go to the resume slideshow and then go press the down arrows.
Okay. I think that is okay. You have to live with this only.
Yeah. Okay.
Okay.
Go down arrow. Down arrow.
Yeah. Is it
Yes,
okay?
sir. Yes,
Yeah.
yes.
Okay.
Okay. The modern day purpose is they basically search for the deposits of precious element, rare earth elements, and deposits of the radioactive elements as uranium and other things, etc. That was done about 100 years back or so. But afterwards, they found that there's no precious elements like gold or any diamonds there, but it is only mica is available. That too is a deposit in small pieces in the stones and other things, etc., which is very difficult to extract. Okay, so that purpose was lost. And presently, expeditions are made for scientific, political, and social reason, whether geographically and astronomical studies. We may, for our purpose also, we had members of the team from the geophysical sciences, earth sciences, astronomical. We had a three-member team from to study the sun. To study the condition on the Earth in the earlier times by investigating the frozen ice deposit undisturbed. Since they are remain undisturbed, we drill the ice, take out the sample, and then study. Yeah. And to explore the sun in the past by studying the deeper ice sample, by digging the deeper drilling and taking out the ice sample which remains undisturbed. Indirectly, as the activity of the sun affects the snow deposit every year. To study the sun and stars without the day and night cycle. So you have to carry this telescope and install it there. We made the expeditions to study the physical and dynamic properties of the calcium K network on the sun, which Dr. Paniveni already explained. So, how to plan for it? Basically, you have to make a plan, project, and then give it to the review committee. The review committee will listen to your project, and if they are satisfied that it can be done only from Antarctica region, but not from anywhere in India or anywhere other places, then they say, okay, this can be done from Antarctic region. You can make the expedition. Then you do the feasibility study whether this is possible to be done. Scientifically, you might be right, but whether it is possible to be done. So then you have to develop new instrument suitable for operating in Antarctic region, since it is a very cold region and cold region, and then you have to prepare for it that instrument should be able to operate in the -10 degree temperature kind of a thing. So you have to develop that. The physical fitness of the scientist going is tested in great detail. Your eyesight, your BP, and other things, etc. Your uh, health issues that you can bear the hardships of the Antarctic region. If found good, training is given at high altitude cold places, mostly in the Himalayan region, to face the Earth's harsh climate condition and identify crevices. Crevices are generally top surface remains like a solid, clear surface. What there might be ditch means below that solid surface there might be nothing. So if you fall in that, you cannot come out of that. So that is crevices, and avoid these while walking on the hard ice. Since it is an unknown place for the person going for the first time, we need to know what is available there and what we need to carry with us. So that is how training is given at the Kulu Manali. The 25-member team was taken to Kulu Manali, and we have to walk about 10 kilometers every day, 10-15 kilometers every day at the high altitudes. So they wanted to check your stamina, and then they can tell how to. So when we have to carry on the ice, move, then people tie a rope around their person, around their vest, and then move. So that kind of things are told, so which we have to follow in the Antarctic region. And then once we reach Goa, then we have to Secretary DOD, Dr. Gore came there, and we had to explain and satisfy him that we are ready for everything. We have all the equipment and we have prepared well. So once he need to be satisfied. And he was the leader of the whole team. I was the leader of the astronomical team, but he was the overall leader. He was going for the second time. Uh, then we reached the Goa, and so sometimes families come to say goodbye to you, and these are Air Force personnel. And team consists total. There were 86 people, and people from defense, people from army, navy, and there were 26 people from the scientists from various departments, and Air Force personnel takes care of their travel from ship to the Metri Island or wherever we want to go by using the helicopter. Army personnel takes care of the station, generators, vehicles, and so many other things. And Navy personnel takes care of the communication. Crew generally manage the ship, and there are two team, 26 members, and there are have two teams. One is summer team, another is winter team. Summer team comes back after 4 months. Winter team comes after 14 months. Then this is a team which we have to all the scientists. And next, once we travel, beginning when we start from the Goa, sea is quiet. But as then we come across skua, which is a very large element bird. It has about 1 meter wings, and it can fly hundreds of kilometers without any rest, kind of a thing. It does not use its wings to go up, and generally it moves by the air currents so that it can fly for a long time. It rests on the water only. Then when we reach about 40-degree latitude, sea becomes very rough. We call it crying 40s and 50s. And their sea becomes very rough. We have ship also starts swinging in both directions. So we have to wind up everything back in boxes. And it takes about 2 days to cross that latitude, rough sea. Then we generally live on soup. People get seasickness and other things, etc., vomiting. And after we cross 60s, sea becomes quiet again, and we come across icebergs. Icebergs is snow pieces, not piece actually, big running into kilometers, half a kilometer, and 200 meters. And then various icebergs kind of a thing. These are broken pieces from the Antarctic region of ice. Once we reach the Antarctic region, and sea freezes in winter, and we have to go closer to the dockyard, kind of a thing. Then ship gets stuck. So we have to find out which is the easiest route to go over at our destination. So we take out a helicopter from the below, and then we do the recce. After doing the recce, find a place for how to go about it. And once we reach a ship, then manage it by breaking the ice, and then reaches at the Antarctic region. Ship stays there. Then we travel from ship to station by helicopters. And now I come to the physics. What you see, the sun, yellow. Generally, when you get up in the morning, you see a red ball, a red yellowish ball, which is what you see. But sometimes you see black spot. Sometimes they are the naked black sunspots, but they are rare, kind of a thing, etc. They are seeds of high magnetic field. And then this is the calcium picture of the sun, which is a chromosphere. Okay, and so this is taken in calcium K light, and then it shows plasmas and other thing, and there's network cells which are about 30,000 kilometers or so, 20, 30, 40,000 kilometers in size. So they have a lifetime of about 20 hours, 10 hours to 40 hours. We want to study them. So if you want to study them, you need a data for about more than 24 hours or 30, 40 hours continuously without any day and night cycle. So this is, if you look at the sun at various high temperature lines, like you see the magnetic network here, and this is when you see at corona, basically, if you see an emission line from the sun, which spent a temperature of 1.3 million degree, and this is about 2 million degree, you can see the X-ray, you can see the sun on any given day, but in white light, you cannot see the outer atmosphere. So supergranulation basically was discovered in 1956, and Leighton made the great detailed study of the supergranulation network, and they found that the size is about average size is 30,000 kilometers, and average life is 20 hours or so. And there's a horizontal flow, and the material flows from the center of the cell to outer boundaries, and it carries the magnetic field along with it and deposited at the boundary. And the speed is about 3,000 to 300 kilometers to 500 kilometers per second. And then this is what velocity pattern. Okay, so it shows that the center you don't see much of the supergranulation when because the flow is horizontally. So line of sight velocity is almost zero, very less, so you don't see much about it. Whereas here line of sight velocity becomes prominent, so you see the network cells known as supergranulation. Okay. So properties I already explained. This average size is 30,000 kilometers, and velocity is about 0.5 kilometers. From it is a horizontal flow from center to the boundaries of the network, and lifetime is 10 to 30 hours or so. And there is similarity in the appearance of this calcium K network and the magnetic cell. The appearance and properties of the cells suggest that these are the surface manifestation of supergranulation. Calcium K network are the surface manifestation of supergranulation. Supergranulation is basically very large. It starts its journey from the base of the convection zone. So they are deep. So convection current starts and then they come up, and they help in transporting energy from the from the bottom, not from the core, but about 0.7 radius of the sun to the surface of the sun. So that is the convection zone, what we call convection zone. And supergranulation transport the energy from the base of the convection zone to the top of the convection zone. So why? Now what happens is a lot of studies have been made of these large convective cells. Hagner found that cell size is not 30,000, but it is about 13 to 18,000 kilometers kind of a thing. So there is a discrepancy little bit of kind of a thing. And next is Shrikant and myself did the autocollation of the images and other things that have lost, use the calcium K network and use the SOHO Dopplograms. And then we found that the cell size is about 14 to 18,000 kilometers. Okay. And what it also depends upon the resolution kind of a thing. And sometimes we found that distribution of the supergranule size is about 25,000 kilometers. So there's a different results coming up, and we again found that there's a variation of the cell size. Average cell size is low. Average size is smaller as compared to the at the maximum phase of the solar cycle, and as compared to the minimum phase of the solar cycle. This cell size varies with the phase of the solar cycle. That was one finding by using the Kodaikanal data. Okay. So then we use this Kodaikanal data. We found that it is related with the strength of the cell. This line shows that as the strong, these are the minimum period, cell size during minimum period. This is the average cell size during the other maximum phase of the solar cycle. So you see that average cell size is more during the minimum period as compared to the maximum period. So these findings were done. A limitation of this data. We have used a lot of data people have used. All these studies are based on the data obtained less than 10 hours a day kind of a thing. And the result differs. Since data is not continuously, data is only for 7, 8, 10 hours. Then the night comes, so you cannot see the sun. So you cannot observe. The average lifetime of these cells is 20 hours with a range of within the range of 10 to 40 hours. Therefore, continuous data are needed for more than 40 hours without the day-night cycle. So you need a continuous data without any break for about 40 hours if you want to study the formation and decay of these large convective cells. Okay, since large connective cells and calcium K network cells are related, so that is what you can do. Is continuous data can be obtained from space either or from Antarctic region where one can observe the sun at midnight without the day-night cycle or space telescope placed at the proper orbit. If you put in the geocentric orbit, then also you will come across the eclipses kind of a thing. Period is 19 minutes only, and for 90 minutes you will be observer. But if you put the satellite in the polar orbit, so you will be able to see the sun 24 hours a day. Hence the expedition to Antarctica. So you can see that this region, you can see the sun at midnight. It was a midnight on the sun. And this shadow is there a little bit because of the glacier. Okay, glaciers interrupt the sun for about 30 minutes or so during the month of December, January. So after reaching there, I'm taking a little more time. We have to install the telescope, and there's nothing. We have to carry the woodlock, then put the platform, and then put our instrument together. We are to do. Then we are ready with the equipment. And I will not go in the details about this instrument, since it is an amazing kind of a thing. Instrument for imaging. This is the close-up view. Basically, this is a mirror which reflects the light, and this is specially designed to operate in Antarctic region. Okay, and then it falls on this mirror, and then image is formed. So what happens is the image is formed here, and we have a camera. Those days, CCD cameras were not common, so we have to depend upon the photographic technique of taking the images of the sun. So we were using this camera here. But the camera problem was that it was being operated on the cell. You know that all these cameras needs button cells. But the button cells will work for about only half an hour or so because of the cold climate. Temperature was about, even during the sun's shine, temperature was about 4 degree to 5 degree kind of a thing, etc. So then cells will stop working. So I will take out these cells, go to the room, and then change the cell again. Not keep these cells in the warm place in the pocket inside my body. So these cells will become warm, and every 45-50 minutes I will be changing the cell. So then we were keeping these films together, and then we have to develop a kind of a thing, etc. And those films, we have taken the developer and all those things, and then we used to reload the spools. Since every day we will be using something about 30 to 40 spools, we have big rolls of the film, and then we will I had a limited spools of about 100 or so, so we have to empty those spools and fill in the new film and then use it again for next day. Okay. Live. So this is what we found it after we take the continuous data. This is a picture of the calcium K of the sun in calcium K light. Data was we were lucky, as Dr. Panivani told, we were lucky data obtained for 106 hours with a gap of about 45 minutes every day, 24 hours with the interval of 5 minutes. Okay. Data were used to study the lifetime of the calcium K network to compare the lifetime in the active region and the quiet region. So during this, for 106 hours, I did not get any sleep. I was just working all the time, 106 hours. And that 45 minutes with the gap was there, but I did not want to sleep. I will just, since 45 days minutes I have to use to get ready for the next cycle, fill in the spool, make the more spools, and empty the old spools, all those things. So lifetime of the active regions, we find the average lifetime of the cell is more in the active regions as compared to those in the quiet regions. This implies the diffusion rate is more in quiet regions as compared to the active regions. So this is the implication. We found this result for the first time. People may expect these results, but we found for the first time. And then the relationship between the cell size and the lifetime for the active region cells. So we chose calcium K network, which was close to the active region, not exactly to the sun, close on the sunspot, but a little away, but away from the quiet region, which is closer to the active region. And we studied that. And we found the cells, this is cell size, axis is cell size, and this is lifetime. So that means the linear fit shows that cell size is related with the lifetime. If more the area of the cell, lifetime is more. And similarly for the quiet region, and the relation holds for the quiet region. Then apart from this, there were other experiments which were done. We have the people from med department. So they were interested in knowing the temperature profile with the height. So every day when we were going, we started this experiment when we were going at a different going to Antarctica itself. Then every day we will fly the balloon, and then it will send the data, how the temperature, pressure, etc. varies at different part of the sea on height at the sea, kind of. Such data is rare. Only you can monitor during the expeditions only. So that helps, kind of a thing. And then atmospheric sciences people from person, they were taking air samples and other things, etc. And then air samples are taken and water samples were taken at a ship of the sea, kind of a thing, etc. They were doing their studies, kind of. And then at Antarctic, we have taken material for installing, making a greenhouse. Since Antarctic region, you have to take the tinned food, which is, and after some time you get bored with the tinned food. And fresh food is always required for the people who are staying for the long time. So we took the glass, made a glass house. We had to make the foundation. Everybody has to take part in these things. We have to dig holes and then install the pillars and other things like this, and then make a greenhouse. And we carry the tinned food. We don't have much refrigeration, kind of a thing, etc. The non-vegetarian food like meat and other things, we have to store in the cold places. So we don't have so much refrigeration facilities there, and the power problem is there. So we use caves, and we transported food from the ship to the caves, and then people in the winter team, then they can take out from the caves and the thing. And this helicopter is being loaded, and then since they have to put the material to the station and various places, since people are going to various places, the petrol has to put at the various places. So helicopter does this kind of thing. This telescope, and the helicopter makes trips from this ship to the Matthew station. So this is again the atmospheric experiment. And this 12 we were monitoring, continuously monitoring temperature, pressure, etc. at the various sites, kind of a thing. And these are various instruments for these things, etc. And then we do celebrate when we cross the equator, and then they say the sea god becomes uh, annoyed when you cross the equator. There's a feeling that sea god becomes annoyed, uh, and I'm a little faster, so that since time is running short, and then we have to pray the sea god so that he does not get harm us, kind of thing. Then we celebrate 26th of January, Republic Day, and then we play with the penguins, kind of a thing. Sometimes we get some time, and then they stay in rukris, kind of a thing, and they run away if you stand and walk. So you have to bend on your knees, walk closer to them, to have a good look at the sea penguins. Then we enjoy this snow ride also, ice ride, kind of a thing, etc. Snow scooter is there, that kind of a thing, etc. Okay. And then finally, uh, we were given 12 minutes, kind of a time, to talk to the family. Okay, for the full 4 months, we had only 12 minutes. And during those days, it was not easy to talk. The signal was going through 7 satellites, and we will be just calling hello, 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 hello. And we were just hearing the sound without conveying anything, etc. Thank you very much for your kind attention.
Thank you very much, sir. Now there is time for some questions. Anybody would like to ask a question, they may do so.
Yeah.
I'll start with a simple question. Were there any clouds, fog, rain, or snow there at Antarctica? Did you face any problems with them?
Yeah, actually, there was blizzards. Actually, yeah,
Ah,
and there were most of the time sky was cloudy, kind of a thing, and it will clear for 1 hour or half an hour, kind of a thing, etc. So it was only one time when we got continuous clear sky for 106 hours. Okay.
ah, ah,
Okay. So other times it was cloudy and snowing also, little bit. What problem comes when blizzards come?
ah,
This wind speed becomes 100 kilometer, 200 kilometers per hour, kind of a thing, etc. You can see the snow here. Then when the some weather forecast is there, try to look for the weather forecast that blizzard is expected. We tie all our helicopters with the deck, kind of a thing, etc. So we don't, you see the rope, it is tied from all the sides. Otherwise, wind will take it away.
ah,
Okay? And we are not, the visibility becomes very poor.
ah.
Uh, 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 Making a estimate of the distances becomes very poor. So nobody is allowed to walk on the deck.
Ah.
Everybody is advised to remain in the indoor, in the rooms, kind of a thing, etc. So we don't have any activity during the blizzards,
So
kind of.
the sun is really not visible all the time. So you have to wait for the proper conditions. Only then the
Yeah,
sun becomes available for study.
yeah, that's it.
Okay, Professor Swami, you want to ask a question?
Sir, thank you, sir, for a nice talk. So what is the total time takes from Goa to Antarctica
It took about
in
25 days.
ship-wise?
25 days.
5 days, 5 days.
5 days, 25 days.
So this helicopter facility is available, sir, nowadays to
Pardon?
reach helicopter facility.
Helicopters.
Helicopter.
You see, helicopters, no, generally what happens is, uh, generally you can't fly from there. And there's, from South Africa, you can take the air flights, kind of a thing, etc. Americans, they do it. They fly from South Africa. They have the base camp where they have some kind of their aircraft can land there. Okay, but we don't have any kind of aircraft facility which can fly from South Africa and other things. Since it is uh, expensive work to fly from there to Antarctica. It is not a commercial. It becomes much more expensive if you try to fly. And secondly, you need special aircraft. They cannot fly with these tires and other things, etc. Okay, they have to have a skiing kind of a thing, and the runway has to be. There's no proper runway. It is only ice kind of a thing, etc. There has to be flat ice for some 20-30 kilometers. Okay, so Russians have such facility sometimes. Once in a while, they do send the aircraft, but only in rare circumstances. But that is also away about 100 kilometers from our station at Matri. And the sad part was that during our expedition, 4 people died because of carbon monoxide poisoning. And then there was no way to send them to India. So then we kept them for about 25 days or so. Afterwards, Russian aircraft, we requested Russian aircraft that somehow planned to come to the Russian station in the Antarctic region. So we carried the bodies there, and then that aircraft landed. Temperature was about minus 18 degree at that time. And then they took it to Russia, and then from Russia they sent it to India. So there is a possibility, but they are rare kind of.
Okay, Professor.
Yes. Sir, thank you for the nice talk, sir. I have two questions, sir.
Yeah.
One is, I remember I have read somewhere that the temperature of the ground and atmosphere will be around minus 70 to minus 80 degrees centigrade, around that temperature.
Oh, yeah.
But in the photographs, I see some of them not wearing warm cloths and things like that. So how will they manage? Actually? How did they manage actually?
Yeah, that's a good question. Actually, when we went to Antarctic Metri station, and then we were wearing heavy clothing. Temperature was about -4 or so. Heavy clothing, snow suits and other things, etc. Sweaters over the inside the warm clothing, then snow suit and other things, etc. What we found, one person was walking with the shirt. So he was there for about 14 months. So probably only one person was there walking with the shirt. Others was wearing jackets and other things, etc. So
The second thing is,
he got used to it.
Okay, second question.
Staying,
so second question is,
Second.
you go, I mean, you land somewhere and this thing, ground, and then go deeper into the Antarctica, or directly the helicopter lands on the ice mass?
you see, we have at the Matri station, okay, we have a helipad. From the ship, helicopter flies and then land on the helipad. I showed you this downloading, loading kind of a thing.
You showed that, yes, it's correct.
That is loaded. Here, when helicopter is coming, there's a helipad. Okay, so it lands there, and we have to download all the material which it is carries, kind of a thing, etc. This is at the ship. Okay, and this is the cave actually. So when we shift the material, okay, and then it is not carried by the vehicles or anything. Helicopter carries the material from the ship, and it just lands there somewhere. There's no helipad, nothing else. It finds some place. Those pilots are well trained, and they can land in stones, they can land on these things. It is dangerous to do that, Generally, if they land in India or somewhere else like that, they will be inquiry committee will sit in. But here they are permitted to do all those kind of a thing, etc. They land wherever it is like possible.
Dr. Paniveni.
Thank you, sir. Thank you.
Dr.
Yes,
Paniveni, ask your
yes,
question.
sir. Thank you for a very interesting talk and the great feat and the most spectacular feat to go to Antarctica and make observations. In those days, it was actually very tough, and you have done it, sir. And my question is, you said that the device was specially designed to make observations of the sun, to take images of the sun. In what way it was designed specially? Can you please briefly explain?
Very technical question.
Yeah, generally what happens, the system, solar system you would have seen in Kodaikanal and working there,
Ah,
they can observe only 10 to 12 hours kind of a thing, etc. So we wanted to operate for 24 hours a day. So
yeah.
then design has to be different. So we studied various things and then found that this system can work 24 hours a day. So we designed it. That's all.
Dr. Kulkarni, Arvind Kulkarni, please ask a question. Dr. Arvind Kulkarni, you may ask your question.
Yes, yeah. I'm very happy to listen to the talk, a lot of new information. I just wanted to remind Professor Jagdev Singh that we worked together for about 6 months in IIA in 1980. Does he remember me?
Yeah,
Arvind
sure,
Kulkarni.
sure.
Do you
I do
remember me?
remember. I do remember that. I
1980.
do remember you.
6 months I was in IIA and we had some interaction.
Yeah, sure.
Yeah,
I do
I'm not a
remember.
solar astronomer. I'm basically then I moved on to the planetarium. Thank you very
Yeah,
much. Wonderful
yeah.
talk. Wonderful to remember you.
Yeah, I do remember it. I do remember that you
Wonderful
went to
remembering you. Great.
planetarium.
Now, R. Srikanth, would you like to ask a question? R. Srikanth. R. Srikanth, you may ask your question. He's not there. Professor Hemant Kumar, you may ask your question.
Yes, sir.
Yeah, please.
It was very nice talk and very informative, sir. We learned so many things about Antarctica. My question is that do we have some effect of extra ultraviolet radiations at Antarctica at your stay there, or more sunburns there, or more effect of ultraviolet radiations there?
Yeah, and you are right. Since there is more ultraviolet because there is no dust kind of a thing, etc. Weather is very dry kind of a thing, etc. Okay, and so ultraviolet is there. So whenever sun is there, generally we are, if you see clearly, we are using these glasses. These are basically, and during the cloudy days, we can take it over the head. But whenever sun is there, sunlight is there, we use these glasses. And actually, if you see, here you can look toward the sun in India, but there you cannot look at the sun at all, kind of a thing. You had to use always the glasses. These are ultraviolet glasses, so we have to use it. So they filter that out, the ultraviolet. And secondly, one has to be very carefully. Sometimes mm, there is snow peaks, and that snow, there are curvatures and other things, etc. Sometimes they play as a part, like a lens, okay, parabola or something, etc. And they can converge those rays, and if it falls on your eyes or something, etc., it can harm you or your face and other things, etc. Generally, such things don't happen, but while walking on the ice and other things, in the sunny time, one need to be careful. We have to take precautions.
R. Srikanth, would you like to ask any question?
Yeah, am I audible?
Yeah, you are audible. Yeah, please ask.
Thank you very much, sir, for the wonderful talk. I have a non-solar question for sir.
Yeah,
In one of your earlier slides, you mentioned about endurance.
yeah.
As I believe, endurance is now sunken, right? It is no longer. But then you seem to be showing a sailing boat. So I was wondering, what is that sailing boat? I don't think it's endurance, right?
No, it is not Indian. It is not Indian.
No, endurance. That endurance that Shackleton and others they had in 1915, I think. They had that,
1950.
it's a stock.
1915.
Yeah.
1915.
This
No,
is what I got from the internet, from the.
you photographed it.
No. There are
You went
so
to
much about the expedition. There are each expedition. There are books on that. So I got from them. Since lot of year days, since communication, what happened? Local summer when it is about month of December, January. These are the only 2 months, February. Okay, when one can see the sun 24 hours a day. Rest of the time, sun goes to the horizon. Once it reaches to the horizon, you cannot see it. This uh, image quality becomes very poor. So data available is only for 1 month or so.
Okay,
That's all.
Professor Nagaraj,
Yes, sir. Before
yeah.
the vote of thanks, sir, no expedition is done with respect to Arctic region.
Arctic
Yeah.
region.
You see, Arctic region, generally people have taken the telescope to the Greenland. Okay. And that is, since it is possible to go to a Arctic region, so you don't need the expedition from Europe. You go to Arctic region, greenhouse kind of a thing, etc. So there people have made some observations. And secondly, there is no land mass there. It is only ice. Whereas the Antarctic region base is land mass. So that has the attraction. So that is how the expedition started to look for the precious elements and other things, etc. That's
Oh, thank you, sir. And one more thing,
yeah.
as far as the activities of the sun concerned, Hubble telescope is also making observations. So, in what way the observations made by Hubble telescope and then the telescope from Antarctic region?
You see, the thing is, we wanted to study particular feature of the sun. There are many things of the sun to study. Whereas Hubble telescope makes the study of galaxies and other things, etc. Okay, there are so many satellites. Even now, Adithya L1, we have launched in 2023. Okay, that is also making studies of the sun, outer atmosphere, various kinds of studies. It is like Aditya L1 is a mini solar observatory, okay, which is looking at the sun 24 hours a day, okay, and it is looking from last January itself,
January 6th.
January 24. So already almost going to be 2 years kind of a thing, etc. And it will continue to look for another 4, 5 years or 10 years. Okay. So we are making studies from space also. Okay. And Hubble is only devoted to night sky objects like galaxies, stars, and other
Not sun
things.
so much. Yeah. Not sun so much.
Not sun. And what is, there are various other satellites like Yoko, Hinode,
So,
Soho. There are very number of satellites which are using studying the sun.
okay, Professor, I request now our General Secretary, Professor Nagaraju, to propose a vote of thanks. Okay.
Yeah, thank you very much, sir. In fact, you have enlightened about the experience you took from that expedition and training, how it is given. All those things you have explained. And like that, how many astronomers have gone there so far? Yes, could you just tell me only one sentence?
The thing is, what happened? India has done only one. Okay. And then there was a small expedition which we went from South Africa to study, to observe the sun during the solar eclipse in 2003. Okay. And may I add to this is that when Dr. Paniveni told me to give a talk, I was wondering on what subject I should give the talk, whether on Aditya L1, which we have launched in 23, or whether on Kodaikanal Observatory, or whether on Antarctic region, weather, my observations from Japan. Okay, so many subjects I was thinking. Then she told me that to give a talk on Antarctic region. So that's why I gave the talk
Very
on
interesting.
Antarctic.
Yes, sir. Yes, sir. It is a very good talk. I know at least we got an information that how the training is given and how you have part of the expedition. Thank you very much, sir. In
Thank
fact,
you very much.
you have spent your time to give a talk on this expedition. So thank you very much. So we should
Thank you
thank
very much,
Dr.
all.
Penivedi
Thank you for
also
arranging the
with
talk.
this.
Thank you very much. Bye.
Yeah. We should also thank Dr. Paniveni because she only has organized this talk, and Dr. B.A. Cogley, and also
Raghavendra.
Jnanadhara, Dr. M.K. Raghavendra, who is providing this platform every Sunday. And in addition to that, S.V. Raman, that is Venkat Raman, who is actually providing us the YouTube. And I think some guests are also attending this talk. So from KPA, Karnataka Physics Association, we thank them, and we thank our members also, and thank each and everyone who has participated in this talk. Thank you very much, sir. Thank you. Maybe Pogli has got some information to give us.
I'll inform you, but so let me thank you, all of you, for participating in the webinar. Now we are ending the meeting, so let us meet next week at the same time. Thank you very much.